Happy Monday, Rocketeers. I'm going to get us started with our read aloud. But this read aloud will be a little bit different. We'll be doing a read aloud and a reader's workshop kind of combined. So I am relying on the fact that you watched the previous video about maps and globes. So if you have not watched that video, please go do that now before starting this one. So I know last week I focused in on a skill of reading a nonfiction text and really focusing in on the headings and how the headings can help you better understand the main idea of a nonfiction text. And today I'm actually going to be zooming in and kind of focusing in on how the key details or supporting details, how they and the illustrations team together to help you better understand the main idea of a nonfiction text. So I'm going to pull this up for you and read it to you. This is sort of like if I had you in the classroom, this would be on an anchor chart. So this is the what. This is what we're doing. Illustrations are drawings of the things that are happening in the text. Key details. Key details are pictures and words in a text that help us understand what is happening in the text. Key details can usually be found right there in the text, but sometimes have to be inferred too. Key details are details that support the main idea. Key details can tell us about who is in the text, where and when the text takes place, what is happening in the text, and how and why the problem and solution occurred. How? So how do I do this? I pause at the end of each page or section of the text. I would ask myself, what are the most important key details the author teaches me about in this section? And then I would look at the illustrations, the pictures. And I would ask myself, how do the illustrations help me understand more about the key details I read about in the text? Remember, touch your brain. Great readers use illustrations to help them better understand the key details in a text and how they are connected to the main idea of the text, okay? So the illustrations connect to the key details, you put them together and it helps you understand the main idea of the text. So I'm going to look at one page, take this out, of the text. So I want you to really focus in on this picture for 1 second. Normally in a book, this would be side by side with this page of text. So let me get us started. So we read this page last week. I'll read it to you one more time. Thousands of years ago, our ancestors invented the map. Ancient maps were crude but very useful tools. They helped people find food, clean water, and the way back home, even when home was a deep, dark cave. So going back to our objective for today, I know that great readers use both key details in the text and illustrations to help them understand the main idea of the text. So after reading this first page, I'm going to stop and ask myself, what are the most important key details the author is teaching me about in this section? This page teaches me that people used basic maps thousands of years ago. This is a key detail that is connected to my main topic because it explains how the first maps were made. Next, I'm going to look at the illustration that accompanies those words. The illustration shows me two people that are drawing maps in the dirt. I notice that these maps are mostly just lines and shapes. There are no labels or directions like I've seen on maps that are used today. Finally, I ask myself, how do the illustrations help me understand more about the key details I read about in the text? The text told me that people used basic maps starting thousands of years ago, and the illustration helps me understand that these maps were lines drawn in the dirt on the ground. This helps me understand how different ancient maps were than the ones that I've seen used today. Now I'm ready to keep reading to find out how these ancient maps developed into the maps that we use today. So this was me modeling you that skill of using illustrations and details in the text to describe then the main idea. I'm going to continue reading this text from where we left off. And then when we do our Google form, I'm going to be posting in that some questions that relate to these key details and illustrations. So I really need you to go on the Google form today after watching this video and fill out those questions for me so that I know if I need to do this lesson again and try to explain it differently for you. So I'm going to go down to where we left off. And remember, I'm paying attention to the illustrations and paying attention to the key details in the text. So last week, I know I stopped at this page, so I will go right here. All right, let me make this easier for you to see. Globes are tiny models of our Earth. Globes, unlike flat maps, are shaped exactly like the Earth, like a ball or sphere. They are very tiny models. The Earth is really 30 to 40 million times bigger than the globe in your classroom. Globes, because they are round, put all the world's geography in its proper place. They give the truest possible view of the whole Earth. Maps put our round Earth on flat paper. Maps are precisely drawn pictures of the Earth, pictures of the entire Earth or any part of it. There are maps of the world, maps of the country where you live, and maps of your hometown. Maps put all the wet oceans and all the lumpy, bumpy land on sheets of nice, flat, dry paper. Globes are the most realistic world maps. Since globes duplicate the true round shape of the Earth, all distances, directions, sizes, and shapes are true to scale on globes. But maps must artificially flatten the real round world. So map makers cut, stretch, and distort some parts of the Earth to get it all flat on paper. The worst map distortion is at the top and the bottom of the world in the Arctic and Antarctic. Greenland, for instance, looks bigger than all of South America on a flat map, but it isn't. A globe instantly shows that South America is really much bigger. In fact, it's 8 times bigger. Maps have a language you can learn. Maps and globes can take you places and show you things when you know how to read them. Map language is partly names and numbers. It's also bright colors, great circles, imaginary lines, and tiny symbolic cartoons. Map language begins with the 4 basic directions. Direction means which way. North is the direction toward the North Pole from any other place on Earth. South is just the opposite. It's always toward the South Pole. East is the direction where the sun appears every morning, and west is towards the sunset. The equator divides the Earth in half. The equator is an imaginary line, is a great imaginary line around the middle of the Earth. It divides the Earth into 2 equal parts, the northern and southern hemispheres. A hemisphere is exactly 1/2 of a sphere. The northern hemisphere is the half that's north of or above the equator. Most of the world's dry land and most of its people are within this area. The southern hemisphere is everywhere south of or below the equator. Of the 7 continents on Earth, only 2, Australia and Antarctica, are completely within the southern hemisphere. The equator is 25,000 miles long. That's a great circle. How to put big countries on small pieces of paper. Distance is how far apart places are. Maps and globes miniaturize the actual distances. They are drawn to scale. Scale is the system that reduces the real land, the real oceans, to sizes that fit on paper. Scale lets you hold millions of square miles in your own 2 hands. To find distances on this map, measure the inches with a ruler and 2 multiply by 500. The map distance between San Diego and Boston is about 5 inches, so the real distance is about 2,500 miles. On this map, 1 inch equals 500 miles. That's its scale. You can measure the Earth with a piece of string. Globes differ in size, so they differ in scale. The exact size of any globe is shown in its key or legend. To find mileage on a globe, measure the inches with a string, Then multiply by the scale. For instance, the shortest jet route from Chicago to Calcutta, India, would be due north over the North Pole. This Great Circle route is a long, curving distance of about 8,000 miles. I'm going to pause here, Rocketeers, and I'm going to give you questions on that Google document for this portion of the text. I will take screenshots of parts of the text and I will add them to this post. So make sure if you are stuck or if you don't remember the illustrations or the key details that were given in the text, make sure you look at my post because I am going to be including some screenshots of the book and of the pictures so that you can reference those to answer the questions. Great job, guys. I know this was a kind of a long video, but if you have any questions, please comment and let me know how I can help you. Thank you.